Today we're looking at solving problems with sinusoidal functions. It's your last lesson for this unit. So we're going to go through an example together of something that you could see. But just looking ahead at your homework, just make sure that when you're given a word problem and you're not given a graph, make sure you're drawing that graph so that it can help you answer the questions that you need to answer, okay? So here is a Ferris wheel. We're going to look at a whole bunch of different questions for this Ferris wheel and the motion of the Ferris wheel, time versus height. Okay, so how long will a ride last on this Ferris wheel if you go, excuse me, if you get to go around 3 times without stopping? Okay, so I want to know how long, so I want to know time. So we can see that one cycle on our graph. We start at the middle there, and we're going to go around, and then we're going to come back here. We have one full rotation, rotation or cycle, and then another one on our graph, but we want to know 3 times. Okay, so what your easiest way to do is to figure out what one period or one cycle is on your graph. So you can see highlighted in yellow there that you start at your equation of your axes, you go up to your maximum, back to your equation of axes, down to your minimum, back to equation of axes, which is one complete sinusoidal curve. Okay, oops. So then you're going to know that one cycle is 40 seconds, just looking at that x-axis there. Okay, so then if we want 3 cycles, pretty easy math there. You're just going to take 40 times 3, which is 120 seconds. Oops. Or you are able to convert that to minutes, which would be equal to 2 minutes. Okay? That's a pretty fast Ferris wheel. Okay, next question about this. What is the axis of the curve, and what does it tell you about the Ferris wheel? Okay. So what is our axis of our curve here, or your equation of your axes? So you're just going to find that middle point on your graph. You can take that equation and use the equation if you want, or you can just see. So our highest is 13, our lowest is 1. So the difference between 13 and 1 is 12. 12 divided by 2 is 6, so go up 6. So 1, 2, 3, 4, 5, 6. And you're going to be able to draw a line there at y is equal to 7. Okay, so your axis of your curve is equal to 7, and then you would like a unit there, a y is equal to 7 meters. Okay. And what does it tell you about the Ferris wheel? So it is going to tell you, so if you're picturing a Ferris wheel, this is the minimum that the Ferris wheel goes, and this is the maximum. Well, this is right in the middle. So if you picture a Ferris wheel, right in the middle would be this point here. What is that point called? Well, it's called your axle. Okay, so it tells you how far the axle is off the ground. Okay, so in this case it would be 7 meters off the ground. Okay, another question here. What is the amplitude, and what does it tell you about the Ferris wheel? Remember, for your amplitude, you can use your equation. You can either look, you're going from 13 to 7, or 7 down to 1, or you can use your equation, max plus min divided by 2, which is 13 plus 1 divided by 2. Sorry, it should be minus min, not plus min. I used your axis of your curve formula there, sorry. So 12 divided by 2, which is 6. So you're going from 1 to 7, which is 6, or from 7 to 13, which is 6. Okay, so 6 meters is your amplitude. Okay, all that is telling you. What does it tell you about the Ferris wheel? Okay, so if you're reading what I wrote there, tells you how high above the center of the Ferris wheel you'll go or how far below it you'll go. Okay, another key thing to know about this is that it is your radius of your Ferris wheel. So there's your center, right? Well, you figured out the distance from here to here, which is 6 meters, or from here to here is 6 meters. So that is actually your radius. Okay, that's a good word to use there as well. Oops. Okay, how fast is the wheel spinning? So how fast is your speed? So you just need to remember a speed formula, which is equal to distance divided by time. Okay. Okay, and if you remember for your this formula, you see 2 pi radius. So the 2 pi is coming from that 360 degrees, which is 1 full rotation. Okay, so your speed is going to be 2 pi times that radius, which is 6, divided by 40. 40 is 1 full cycle. Okay. This formula won't change either if I ask you how fast for a wheel, because remember, a wheel is circular. Okay, and then if you do that math, you should get 0.9 meters per second. Don't forget your units there, meters and second for your 2 axes, okay? So that is all of that for this Ferris wheel A example. And now we're going to go on to a second one for Ferris wheel B. Okay, so we're going to sketch a curve that represents a different Ferris wheel. Suppose it has a radius of 3 meters, its axle is 4 meters off the ground, and it takes 80 seconds to go around 2 times. Okay, so you can figure out, there's a couple things that we'll do here. You can figure out some important information. So it has a radius of 3 meters. Remember that radius of 3 meters means that that is our amplitude. The axle is 4 meters off the ground, which means that is our equation of our axes. And then it takes 80 seconds to go around 2 times. So if 2 times is 80 seconds, then what is 1 time? Well, you're just going to take 80 and divide it by 2. So you know that one cycle is going to be 40 seconds. Okay? So I'm going to show you here how this graph is drawn based on the information that we're given. So you know that you're going to have an equation of your axes at 4. So I would start by drawing that at y equals 4. Okay. Then you know that your max is going to your max is going to be 3 meters above that 4, and your minimum will be 3 meters below. So you can figure out your max is going to be 4 plus 3, so 7 meters. And you know your min is going to be 4 minus 3, which is 1 meter. So you can draw those lines as well. And write max. And write min. Okay? Then what you have to figure out is how far apart and how often you're going to draw your dots, because we have one cycle, which is 40 completed in 40 seconds, but we need to figure out, we know that we're going to start at our 0, 4, but then how do we know how far over we have to go? Well, it depends. If you are able to label your graph 10, 20, 30, 40, well, then you know that you can go over 10 and up to your max, over 10 back down to your equation, your axes, over 10 seconds down to your minimum, and over 10 there, okay? But another way for math, if your numbers were bigger and you hadn't drawn your scale yet for your time axes, you can take, to figure out how far apart you're going to put your dots or your points. All you're going to do is take your 40 seconds and divide it by 4. Okay, you will always divide your period by 4 to figure out how far apart those dots go, which is 10 seconds. Okay, so even if your period was 180, you would divide it by 4 to figure out how far apart you put your points. Okay, so that goes for any graph, not just this example. You will always divide by 4. Okay, so that's how you would draw that, and you can continue going on with your next cycle to draw a second cycle there, okay? Just in case you were asked more questions, and because it also gave you, in the original question, it's 80 seconds to go 2 times around, so you should be able to draw your graph to 80 seconds, okay, which would be on the graph there, okay? So there's a couple of examples. We went from looking at a graph to answering questions, and we also were given information and had to come up with the graph. Okay, so you'll see that in your homework. There is 5 questions in your textbook and then a handout to complete. So let me know if you have any questions. Good luck.